We are back to our electronics lab workbench, and I have here a small PWM module for testing, and keep watching. Let's see together what this small thing can do. Hey there, I'm Hugo Ferreira from TechCornerTV, and today we have here this small PWM module for testing and review. This module can generate square waves and, for example, control the speed of a motor or the intensity of a LED. So if you are new here, please make sure you subscribe and hit that bell so you can be notified every time we have new videos. And don't forget, we have two more channels, the Tech Corner Mailbag Day, where we unbox and give the first impressions of everything that comes to the channels, like this, and the Tech Corner Reviews and Tips, where we do the review of consumer electronics. So without further delay, let's start. Well, the first thing that we're gonna do is to install here some connectors to make it easier to connect cables, and in the future test that we will do, make it easier to power it up and to connect it to the test equipment. So let's start by putting this here. It doesn't seem to okay, it entered. As I told before, I want to start to work with SMD, and well, this is not SMD, it's DIP. It has pins, but today we will gonna try for the first time. I will try for the first time solder paste, and try to solder this with the hot air. So we'll do a fast forward while I do this, and let's see how it goes. I start by protecting the module components with thermal glue tape. So then when I apply the hot air, it will not damage anything. After this process is done, I will apply the flux and the solder paste, and using the hot air gun, some hot air on the solder paste until it melts. It's not a very long process, but it still took a while until I managed to melt all the solder paste. The flux helped to have a better final result. In the end, it looked good. So to finish, I crimped some terminals and a plug to the wire, just to make it easier to the connection between the module and the power supply. It's much easier to connect if we have some terminals instead of using the wire. Before moving on, let's talk a bit about PWM, or pulse width modulation. The pulse width modulation has two important components. The first one being frequency, that can be measured in hertz, kappa hertz, megahertz, and gigahertz. The second one, it's the dutty cycle. The dutty cycle can be measured in percentage from 0 to 100. The dutty cycle represents the time the signal is on inside the cycle. Let's illustrate this. Consider a graph that in the Y you have the volts and in the X we have the time. In here we will draw a square wave with two cycles. The first cycle, we can see that is near the 5 volts, so 50% of the time it's on. It has a 50% duty cycle. The second cycle, it's near the 5 volts by all the time of the cycle, so it has 100% duty cycle. The two cycles in 1 second compose the frequency. In this case, the frequency it's 2 Hertz because we have 2 cycles in 1 second. 2 Hertz. This is the frequency. The frequency and the duty cycle combined can control the power output of a PWM generator like our small module. So the duty cycle is the percentage of time the signal is on inside 1 cycle. The number of cycles per second makes the frequency. So let's see how this works in the real life example with our oscilloscope. Okay, so let's start analyzing here our small module. Let's peel off the plastic protection. We have here 3 channels controlled by those buttons, the dutty cycle, and this one controls the frequency. In this side we have the pin connectors for the channels, 3 channels. We have a COM output for connecting and the power input. Let's see the back where we have Nuvoton N76E003 IC controller and a Holtec HT1621 display controller. This is a fairly simple module. Now let's see how it works. I will connect the power and let's connect it to the multimeter and to the oscilloscope. This is kind of stuck. Wait a moment. Okay. Let's connect the plug to the power socket. Yep, that's it. Let's turn this on. Okay. So we can see already some information in the display. We have here the channel 3 selected with a 45% duty cycle for 100 Hertz frequency. By pressing the duty cycle of the other channels, we can automatically select the other channel and change the duty cycle value. I will connect now here the cables to connect to the multimeter so we can analyze the voltage output of this module. Let me just try to put this here. It's kind of small. Yeah, okay, I got it. Let me just adjust the focus. Yeah. Okay, let's set this in the multimeter and it doesn't seem to work. What is going on? These values are not right. Let me see. I think I connect this wrongly. Yeah, it's not right. Let me try again. Yep. Now it's right, but the values are still not the ideal. Is this well connected? Just a moment. Let me check what is going on here. Let's take this all the way up to 0. Something is going on here. Maybe it's not well connected. Let me check here. Yeah. Not his. Okay, let me take this all the way out, all the way to 100%. And yeah, 50%. We don't have the right signal. And let me check here. Yeah, it seems now it's more stable. Okay, all the way up. 100%. Okay. Now it seems to be working. Okay. 499, it's basically 5 volts. Yeah, 100%. Let's take it to 99 and 50%. It should have 2.5 volts. Yeah. Okay, it seems good now. All the way to 0. Yeah. Okay, almost there. Yep. Okay, it's not 0 volts, but yeah, it's still acceptable. Yeah. Okay, let's try and connect this to the oscilloscope. Let me get the BNC connector. Okay, here it is. Let me just connect these to, okay, it is better on the second channel. Okay, and it's up. Turn the channel on. Okay. And let me just connect this here. This is pretty small and it takes a little effort. Okay, it seems to be okay. Yep, we have here on the oscilloscope, we have a 100% line. Notice that this is at 900%. We have there only a small fail in the line. With 100%, it's a complete line. Okay, let's take it to near half, and you can see already that the square wave is changing. So the dutty cycle right now it's half up, half down in a square wave, and that means that we have a 50% dutty cycle. The signal is only on half of the time. Okay, so let's take this to the to 0. As you can see, right now we have a steady line down, again up, and we can visually see what is going on. Let's bring here a real example, a real world example. I will connect now here to a breadboard with a LED, the oscilloscope, and yeah, let me just connect this. Okay, I think yeah, the power, this will go to the channel number 1. Yep. Okay, it's almost there. Okay, we have something happening right now. So what we have here is a quite simple practical example. Okay, just let me to dim our light projectors so we can see better the light of the LED. Yeah, I think it's better now. Let me just turn this a little bit off. Yeah, and I think we are good now. Yeah, we can see the light of the LED much better. Yeah, it's much better. Okay, so what we have here, it's a LED. We have the dutty cycle to 50%. Just let me connect the multimeter also, so we can analyze the voltage that the circuit has after the LED consumes. Yeah, so the LED, yeah, so the LED needs about 3 volts more or less. So if we take the dutty cycle all the way up to 100%, we should be about 180 volts. Yeah, it's more or less that. Please notice that the LED it's at the maximum, and the line on the oscilloscope it's also at the 5 volts, meaning that the dutty cycle is now 100%. As we decrease the dutty cycle, we can check that the power output also decreases, and the LED is almost off. At 7%, it's almost off. To better understand the frequency, let me change the frequency to 1 Hertz. This might generate here some troubles, as you can see on the oscilloscope. Those wires are not ideal, so we might get here some interference. Let me just to connect this on the other. Yeah, just a moment. It's not helping. But okay, so if we change the frequency to 1 Hertz and the dutty cycle to 50%, what will happen is that the LED will be half second on, half second off, because we have 1 Hertz, a dutty cycle of 50%, it's half of the time on, as you can see. Yeah, please notice the multimeter changing the voltage half the time. Okay, let's see if I can fix here the oscilloscope. Doesn't seem to want to work. I think we might have here something that is not very well connected. Let me change the holes. Yeah, okay. So, okay, let me change. Yep. Still not working. Okay, let's try another channel. Yeah, change to channel number 1. Okay, and still nothing. Yeah, brilliant. Let me increase here the frequency. Yeah, and with higher frequency we have it again. Okay, just let me take it to 100 Hertz. But well, it doesn't matter. What you can see is when we decrease the Hertz, you can see the signal up and down in the light. For example, now we have 1 Hertz with 50% dutty cycle. Let's try. Yeah, still nothing. Okay, let's try to increase to 2 Hertz. Yeah, you can see it's faster. 3 Hertz. Yeah. 4, 5, 6, 7, 8, 10 Hertz. Okay, so we have 10 cycles in a second. So this is a little bit like the animation. The number of frames create the illusion to the human eye. So you can control the illuminance, the brightness of a LED, interrupting the power for a percentage of the cycle. And this can be used in a lot of applications. I've changed the frequency to 200 Hertz, and right now you can see the perfect square line on the oscilloscope and don't see any flickering in the LEDs. Yeah. So with this little module we can have a digital potentiometer for 3 channels with different frequencies. Yeah, it's a pretty good device. It can input 3.3 to 30 volts, and it has a frequency from 1 Hertz to 150 kilohertz. And it can output current from 5 to 30 milliamps. I just changed the light again so you can focus again the display. I don't know if you notice, but the square wave, it's pretty perfect. It's a very good signal. I have here signal generators that can't do such a perfect square wave, even in a low frequency. So, our opinion about this little guy, this module, it surprises by the positive. It is a very powerful module. You have 3 channels with dutty cycle adjustable and frequency and everything else. And you also have a COM output for communication, a serial output. And yeah, this is an awesome module, very cheap, very functional. It was a very nice buy. We will do the tutorial like video about PWM, pulse width modulation, and we will use this module on that video. So yeah, it was a very nice buy for our test environment. Yeah, very satisfied with this. Very satisfied. Very nice module. I hope this video was useful for you. I hope you enjoyed. If you enjoyed, please give a thumbs up. And if you haven't already, please subscribe and hit that bell so you can be notified every time we have new videos. And thank you for watching until the end. See you in the next video. Thank you.